friends, today I, Riya, am standing in front of you to deliver my views on the topic Redox reactions. So, what are redox reactions? Redox reactions are those reactions which are made up of two words, red and ox. Red means reduction and ox means oxidation. Now I will tell you about the properties of reduction and oxidation. So, reduction are those reactions which consist of a removal of oxygen, addition of hydrogen, removal of electronegative ions, addition of electropositive ions, and decrease in oxidation number. On the other hand, oxidation is a process which consists of these 5 steps which are computed as removal of hydrogen, addition of oxygen, addition of electronegative ions, removal of electropositive ions, and increase in oxidation number. I will tell you these reactions by one example. The example is explained as follows. H2 plus O2 gives 2H2O. Here, H2 does not consist of oxygen, but on going on product side, it mixed with oxygen. So this process is known as oxidation because the addition of oxygen is contributed in it. On the other side, oxygen get mixed with hydrogen. In this process, it is known as reduction. So, this whole process is known as redox reaction. Now, I will tell you about the types of redox reactions. Mainly, there are 4 types of redox reaction. First, combination reaction, decomposition reaction, displacement reaction, and disproportionation reaction. Combination reactions are those reactions in which 2 or more atoms combine to each other to form a compound. For example, H2 plus O2 gives 2H2O. Here, hydrogen is one element, oxygen is one element, and these elements combine together to form a single compound which is known as water or H2O. Now, decomposition reaction. Decomposition reactions are those reactions in which a single compound is break down into 2 or more simpler substances. For example, H2O gives H2 plus O2. Here, a single compound H2O is break down into 2 small compounds or 2 simpler compounds which are known as hydrogen and oxygen. Now, displacement reactions. Displacement reactions are those reactions in which the atoms or the ions are changed when they go in the product side. For example, Cu plus ZnSO4 gives CuSO4 plus Zn. In this example, here Cu is singly combined and Zn is combined with SO4. But on product side, this compound is mixed with the second compound and this became alone. But the main criteria for displacement reactions are those reactions in which the active metals or the metals which are highly reactive, they used to displace the metals which are not highly reactive. For example, in this compound, Cu is more reactive and Zn is less reactive. So Cu replaces Zn because Zn is not more reactive. Now fourth is disproportionation reaction. These are the type of reaction in which the single compound is oxidized and that compound is also reduced. For example, H2O2 gives 2H2O. Here H2O2 are mixed with each other and this is oxidized, here this is reduced, and this is reduced, here this is oxidized. These are known as disproportionation reactions. Now I will tell you about oxidation numbers. Oxidation numbers are simply those numbers which are raised up in their powers. For example, there are many criteria for oxidation numbers. Oxidation numbers. There are some criteria to calculate the oxidation numbers. First of all, the oxidation number of hydrogen is positive 1. The criteria for this hydrogen having oxidation number positive 1 is that this hydrogen should be mixed with non-metals. But if hydrogen is compounded or it is combined with metals, then the oxidation number of hydrogen will be -1. Now, the monovalent atoms or the atoms which are singly bonded with each other have the oxidation numbers as 0. For example, O2, here one oxygen is singly combined with the other oxygen. So here the oxidation number is 0. F2, Cl2 and 2, and there are so many examples having oxidation number as 0. Now, the oxidation numbers can also be calculated as, in the case of ions, the charge in the above direction is the oxidation number of that compound. But there is one criteria. In the case of H2O2, O is not having the oxidation number as -2. But in most of the atoms or most of the compounds, the oxygen has the oxidation number is -2. But here the oxidation number is -1, and in superoxide and peroxide, the oxidation number of oxygen is calculated as -1 and -1/2. There are two examples for redox reactions. First is 2KClO3 gives 2KCl and 3O2. Here the oxidation number of Cl is +5, but on the product side the oxidation number of Cl is -1. So here the reduction took place because there is a decrease in the oxidation number. But in the second example, it is oxidation and reduction. Both reactions are taking place simultaneously. So this reaction is known as redox reaction. For example, H2S plus HNO3 gives NO plus S plus H2O. Here, the oxidation number of N is +5, but on going on product side, the oxidation number of N is +2. So the oxidation number is decreased. So here, the reduction process is done. But on the other hand, here the oxidation number of sulfur is -2, and here the oxidation number of sulfur is 0. So -2 is smaller than 0. So here the oxidation number increases. So these are the criteria for calculating the oxidation numbers and for giving the views about the redox reactions. Thank you and have a nice day.